Hey guys, and welcome back to another video on my YouTube channel. In this video, I'll be solving past paper questions on graphs, functions, and differentiation. I'll also be covering key concepts such as solutions to equations from graphs, points of intersection of graphs, finding derivatives, and finding gradients and coordinates through differentiation. So let's get started. I'll be solving question 6 from paper 4, variant 1, May-June 2022. Here's the first part of part AE of question 6. The question says the diagram shows the graph of y equals to f of x for x in the domain from negative 1.5 to 5. Then part 1 of part AE says find f of 2. So basically, the question's asking to find the value of y when x equals to 2. As you can see, we are not given the function y equals to f of x in specific terms of x. So we don't have an equation in terms of x to substitute 2 into and solve for the value of f of 2. However, we do have the graph of y equals to f of x, so we can use that to find the value of f of 2. So basically, to find f of 2, we have to find the value of y on the graph when x equals to 2. I've done this on the graph here by drawing a straight vertical line from 2 on the x-axis to where it touches the graph. Then, from the point where that straight vertical line touches the graph, as I've shown here, I've drawn a straight horizontal line to the y-axis. As you can see, this straight horizontal line from the graph touches the y-axis on -3. Therefore, when x equals to 2, y equals to -3. So the answer is -3. Now for part 2 of part A. It says to solve the equation f of x equals to 0 in the domain from negative 1.5 to 5. So basically, we just have to see the points where the graph of y equals to f of x and y equals to 0 meet. These are the points of intersection of y equals to 0, and y equals to f of x, and the x-coordinate of these points tell us the solutions to the equation f of x equals to 0. As you can see here on the graph, I've marked these points in red where y equals to 0 and y equals to f of x meet. The y-coordinate of all these points is 0. The x-coordinates of these points are the solutions we need. So the x-coordinates are -1, 1.6, and 4.4. Therefore, our answer is x equals to -1 or x equals to 1.6 or x equals to 4.4. Now for part 3 of part A. It says f of x equals to k has 3 solutions in the domain from negative 1.5 to 5 where k is an integer. Find the smallest possible value of k. First, we have to note that the value of k cannot be a decimal or fraction as the question says it is an integer. Integers are whole numbers that can be positive, negative, or 0. They do not include fractions or decimals. So, basically, there is some value of y, which is k, that intersects the graph f of x at 3 points. These are the points of intersection whose x-coordinates are the solutions to the equation f of x equals to k. And this value, k, is the smallest value that does this. So for that, we will refer to the graph. As you can see in red on the graph, the smallest integer value of y that can possibly intersect the graph of y equals to f of x at 3 points is -8. Therefore, k equals to -8, which is the answer. Now to answer part 4 of part A. It says on the grid, draw a line y equals to mx so that f of x equals to mx has exactly one solution in the domain from negative 1.5 to 5. Okay, so first there are a few key points to understand before proceeding to solve the question. Y equals to mx plus c is the structure of any equation of a straight line. In this equation, m represents the gradient of the line and c represents the y-intercept of the line. The y-intercept is simply the point where the line crosses the y-axis. At the y-intercept, x equals to 0. As you can see, the question asks us to draw a line y equals to mx. This does not include c, the y-intercept, so c is basically 0. So, since there is no y-intercept as it is 0, the line will go through the point on the y-axis where y is 0, which is the origin. Now we have to ensure that the line y equals to mx intersects the graph of y equals to f of x only once within the domain -1.5 to 5. To do this, we need to choose an appropriate value of the gradient. The gradient should be such that the line y equals to mx intersects the graph of y equals to f of x at only one point within this interval. In other words, we just have to make sure the line is drawn in a way that it only intersects the graph of y equals to f of x once. The x-coordinate of this point of intersection will be the solution to the equation f of x equals to mx. As you can see here on the graph in red, I've drawn the line y equals to mx in a way that it only intersects the graph of y equals to f of x at one point and it passes through the origin. Therefore, the line I drew in red here is the answer to this question. Moving on to the first part of part B. Here, it says that y equals to 3x squared minus 12x plus 7. Find the value of dy by dx when x equals to 5. First, I'd like to explain a few concepts to help us understand the question better and how to answer it. Dy by dx here represents the derivative of y with respect to x. The derivative helps us find the gradient of a curve at any point on the curve. We know that y equals to 3x squared minus 12x plus 7 is a curve, as it is a quadratic equation. The graph of a quadratic equation is always a curve called parabola, that is either U-shaped or upside-down U-shaped. A quadratic equation whose coefficient of x squared is positive has a U-shaped parabola. A quadratic equation whose coefficient of x squared is negative has an upside-down U-shaped parabola. Moving back to our question, we basically have to find the derivative of the quadratic equation y equals to 3x squared minus 12x plus 7. Then we have to substitute 5 for x into the derivative and solve. So, as you can see here, to find dy by dx, which is the derivative, we multiply the coefficient of x with the power of x. Then, we subtract 1 from the power of x. We have to do this for every term in the expression, except the constant term. This is because the derivative of a constant is 0. This is because when you take the derivative of a constant, you're finding the rate at which it changes. Since a constant value doesn't change, its rate of change is 0. So, the derivative of a constant is always 0. So here, to find the derivative, we multiply the coefficient of x squared, 3, with the power of x, 2, and subtract 1 from 2 for the power of x. Then, repeating the same concept, we multiply minus 12 with 1 and subtract 1 from the power of x. We don't write anything for the constant term as it is a 0. Simplifying, we get 6x minus 12, which is the derivative, dy by dx. Now, we have to find the value of dy by dx when x equals to 5. So, we substitute 5 into dy by dx and get 6 into 5 minus 12. Simplifying, we get 18. Therefore, when x equals to 5, dy by dx equals to 18, which is our answer for part 1 of part B. Now to solve for part 2 of part B. It says to find the coordinates of the point on the graph of y equals to 3x squared minus 12x plus 7 where the gradient is 0. We already know that the derivative of this quadratic equation is 6x minus 12, and we know that the gradient is supposed to be 0. So, since the derivative gives us the gradient at any point on a curve, we know that the derivative 6x minus 12 equals to 0, as 6x minus 12 can give us the gradient 0 for some point on the curve. Solving 6x minus 12 equals to 0 gives us the x-coordinate of that point. So, now we'll solve for x and 6x minus 12 equals to 0. Add 12 to both sides. Then divide both sides by 6. Simplifying, we get that x equals to 2. So, we know that the point where the gradient is 0 on the graph has the x-coordinate 2. To find the corresponding value of y of that point, we substitute 2 in place of x in the equation of the graph. Y equals to 3x squared minus 12x plus 7. Then we simplify and get y equals to minus 5. Therefore, the coordinates 2 and negative 5 are the coordinates of the point on the graph of y equals to 3x squared minus 12x plus 7, where the gradient is 0. So the answer is 2 and negative 5. Now, moving on to the last part of the question, part C. It says when y equals to 2x to the power of p plus qx squared, dy by dx equals to 14x to the power of 6 plus 6x. Find the value of p and the value of q. Basically, we have to first find the derivative of this equation in terms of p and q. Then, we have to compare it to the derivative given in the question and equate the terms respectively to find p and q. Let's start solving to understand better. So first, we find the derivative of the equation in terms of p and q. This is dy by dx equals to 2 into p into x to the power p minus 1, plus q into 2 into x to the power 2 minus 1. Simplifying, we get the derivative dy by dx as 2px to the power p minus 1 plus 2qx. Now, this derivative we just found is supposed to be equal to the derivative given in the question. It's just that our derivative is in terms of p and q. So, if we compare this derivative in terms of p and q to the derivative we are given in the question, we can see that the terms 6x and 2qx must be equal to each other as they both are terms with x to the power of 1. So, 2qx equals to 6x. This leaves 14x to the power of 6 in the question's derivative, and also leaves 2px to the power p minus 1 in the derivative we found. This means these terms must be equal to each other. So 2px to the power p minus 1 equals to 14x to the power of 6. So we can use these equations to get the values of q and p respectively. Let's solve for q first. 2qx equals to 6x. Divide both sides by x. This gives us 2q equals to 6. Then divide both sides by 2. This gives us the value of q, which is 3. Now to solve for p. As you can see, the power of x must be the same on both sides of the equation, which means p minus 1 equals to 6. Solving this equation will give us the value of p. So adding 1 to both sides gives us our value of p as 7. To confirm if p equals to 7, we can substitute 7 for p in 2px to the power of p minus 1 and see if we get 14x to the power of 6. So, substituting 7 for p, we get 2 into 7 into x to the power of 7 minus 1. This gives us 14x to the power of 6. So our value of p is correct. Therefore, the answer is p equals to 7 and q equals to 3. Thanks for watching. If you have any doubts, please comment below and I'll be happy to answer them for you. Please like and subscribe. To find more videos on solved and explained past paper questions on various topics, please view the playlist. I'll be back with another video soon.